Good day, everyone. Just asked a question in the chat. If everybody is here, then we will start in a minute, I think. So let me know that everyone is here, is ready. And I think everyone can hear me.
Hello, I'm here, Modi.
So I guess that we have the presenters of our two first.
Speaker, but can you make it possible for me?
So excuse me. We have. I know exactly that we have the speakers of first two presentations. So we will start, and I guess that all others will let me know during the session. So I would like to continue the session that we started in the morning, and the first. Speaker from St. Petersburg State University, Vladimir. The floor is yours. And yes,
Anastasia, could you please share your slide? I'll say a few words of the introduction.
Yeah, okay.
And then the floor will be yours.
So I guess the camera is here, so we need to sit down.
Okay, so when the slide is there.
Is it clearly here what Vladimir said?
Okay, I will go loud enough, so I will just say a few words of introduction. So this is the work which is done by Anastasia. Mostly is done during her started during her bachelor thesis, and now it's continuing in her master work. And the general topic that we try to investigate is how blockchain evolves and these changes in blockchain architecture, and especially the change of the consensus mechanism in Ethereum blockchain affects the applications. So what are the problems of scalability, how we can use different features that blockchain provides, like NFTs, non-fungible tokens, and such features can be used in the real applications. So Anastasia, the floor is yours. So please, you can start your talk.
Yeah, thank you. As was said by Vladimir, our article, our project describes our experience of creating a marketplace for NFT tokens, non-fungible tokens. And during work on this project, we also pay attention to some key details of working with NFT, such as main token issues, some key protocols for working with them. Also, as it was said, blockchain scaling, and after all, creation of marketplace where we examine cross-chain bridges, NFT splitting, infrastructure design, and also compare our solutions with other. So first of all, let's briefly discuss what is NFT and what key problems it has. So NFT, as I was saying, it's non-fungible token, so some unique token in its kind. But it is important to take into account that the main problem associated with NFT lies in its architecture that is shown on the slide. The main problem is that in blockchain is stored only metadata of such token, and data itself is stored on some external server. So it can be changed or disappear or something. And also don't guarantee some uniqueness. And another key aspect is that there are several standards of tokens in UVM-compatible blockchains. First standard is ERC20. It means some fungible tokens, for example, some coins, gold or silver, something like that. ERC 7021 and ERC 1155 stands for non-fungible tokens, but they are different in the way of transferring the assets. So in ERC 7021, we can transfer only one token for one transactions, and ERC 1155 means that we can transfer several coins in one transactions that will make gas commissions smaller. So, as I already said, that when we was working on the creation of marketplace, it was really important to take into account all the features of tokens and all the specific of working with them. So, in more details, one key aspect is NFT minting. It can be on-chain and off-chain. On-chain minting stands for minting in blockchain at the moment where NFT was making. So, for example, when creator sets metadata and etc., the tokens appears in the blockchain in the moment. And off-chain minting means that token will not appear in the blockchain and will be minting only when some buyer buys it. That means that buyer should pay for creation token and for transferring token to his account. Another problem is not problem. Aspect feature is NFT trading. So it means a way of storing order book. So it stands for all NFTs that are trading in the blockchain, their price, their seller, and etc. It also can be on-chain and off-chain. On-chain means that all information will store in the blockchain, which is, of course, more expensive, but more clear for understanding and safety. And off-chain trading means that order book will be stored in some centralized way, which is not very good. And another aspect is metadata storage. As I was said, metadata in blockchain, there is only a link to NFT metadata, and data itself is stored in some external server, which can be personal HTTPS, for example, file server. It means that data can be changed, that is bad. Data can be deleted also, that is also bad. And there is no decentralization at all. Another way to store metadata is IPFS. It's some decentralized network for storing some files, and in such server, data cannot be changed, and there is a decentralization, but data can be delayed when there is not any validators in this network. And another solution is specialized blockchain for storing files. It's of course very safety, but it's very expensive and also very slow. So in our decision, we saved metadata of our users in IPFS protocol. Another issue that appears when we say NFT is lack of tracking of NFT's creators. So key idea of NFT technology is to enable the creators of token to make a profit by reselling their creations. And since the entire history of transaction related to a certain token is recorded into the blockchain, the original creator can be found easily. But the current Rowley system implies that the creator of the token must manually indicate on each platform where his token is selling what amount of commission he would like to receive from this token. And the problem arises when some buyer of token try to resell it into another platform. For example, in some platform where author of the token didn't register his contract yet, so he will not be able to receive any commission. And this arises due to the fact that smart contract of marketplaces use only some universal transaction, as it is shown on the scheme. First, they receive token value in their own contract, and then call transfer function from smart contract of token. So smart contract of token didn't really save some commission information, and if it is saving, marketplace smart contract doesn't know that it should use this function. So to solve these problems appears a new standard, YAPE 2981. 89. So it provides a function that takes token ID and sale price as inputs and returns the desired commission of author. So marketplace should ask these two functions. But of course, this solution also has some drawbacks. The standards means that the marketplace will voluntarily turn to the function and transfer some profit to it. And currently, of course, only one popular marketplace take into account this policy. It's Rarible, and other marketplaces really don't want to share their profit with anyone. So we integrate this aspect also in our marketplace. Also, it is known blockchain, especially Ethereum, is famous for its long transaction confirmations and high fees. So it was decided to conduct some experiments with scaling of blockchain. And there are two ways of scaling: on-chain and off-chain. Off-chain also have subtypes like optimistic rollups, side chains, plasma, zero-knowledge rollups, Zk-Sync as example, and they are described in more details in article. I would only say that the result of blockchain scaling was much lower than it was expected. So despite the fact that transactions in layer 2 are confirmed almost in the moment, they need to be confirmed in the layer 1 verification. It's orange color, yeah. That takes a long time. So to find some decision of speed transaction, we decided to provide some cross-chain experiments. So, for example, we have users, and he decides in what blockchain he wants to mint his NFT. So blockchain X with more value of NFT, expensive gas fees, and slower operation. And blockchain Y, where his NFT will have less value, minimum gas fees, and faster operation. So in our decision, our user can choose both blockchain. How it is done? So first of all, we created our contracts in each selected blockchain. Then user selects the token to transfer from one blockchain and token in the blockchain that he will transfer it, and start transfer process during Oracle. In our case, it's our web page. So Oracle receives NFT metadata reference, user side transaction of transferring, and also this transaction unlocks metadata from the original token and transfer it into some temporary storage wallet. After that, Oracle checks there is a twin in the database for the chosen token on the selected blockchain, and if there is a twin, he signs transactions, and information of active blockchain in the token is updated. Another feature of our marketplace is NFT splitting. It means that NFT could be split in some smaller NFTs, which are also NFTs, and they can be, after some time, can turn into some parent NFT. It's a cool feature for example, flexible process of managing some virtual real estate. So the architecture of our solution looks like this. We have 3 servers and several smart contracts, and also use some side decision like Infura for blockchain nodes and NFT storage for IPFS storing. So this is comparison of our space with another 2 marketplaces popular, Rarible and OpenSea, and we can see that ArtSpace marketplace smart contracts requires less gas for function, but they need to be paid for creating NFT and putting it for sale, for transparency and security of transactions. So that's all. If you have some questions, I would be happy to answer them.
Thank you, Anastasia, for your presentation. Some questions from the audience, online audience, maybe first. So offline audience, no questions. Very interesting presentation. And can you say some words maybe about the future? Is it some practical some practical results of your work? Maybe I just
yeah, we created this marketplace. We launched it on iOS and Android apps, and also we are at the last stages of designing our website, and I think after that we will make some updates of it, like really scaling, maybe try another ways, or providing another blockchain. So.
Okay, thank you. Hope to see soon your work, your application. Thank you again. And now we will turn to our second presentation by Valery Khvatov. So Valery, you can start. We can hear you. Can see.
Can I share my screen?
We can not see it, but
okay, I try. Okay. Okay.
Yes, we can see. Yes.
Yeah.
Please.
Okay. Good morning, everyone. My name is Well Patov. I am delighted to be here today to discuss our comprehensive paper in blockchain technology fields. I'd like to start by expressing my gratitude to my incredible team, Professors Alex Bogdanov, Alexey Uteshev, and Nadezhda Shogoleva, for their impressive contribution and support. Together, we have developed an innovative approach to overcoming the challenges facing blockchain technologies. What I am excited to share with you today. In 2024, we are diving into the world of the blockchain technologies, what has been around for over a decade since the introduction by Satoshi Nakamoto. Despite its potential, blockchain hasn't become mainstream due to several challenges. Scalability woes, escalating transaction costs, confidentiality caps, smart contract insecurities, interoperability impediments. Different blockchain networks often cannot communicate with each other, limiting their effectiveness. Today, I'll share how our virtual blockchain approach addresses these issues, paving the way for broad adoption of blockchain technology. Mhm. Sorry. Sorry, technical. Okay. Our proposals introduce a groundbreaking virtualized blockchain architecture, inspired idea of ecosystem of ecosystems. Imagine a model multi-component platform where key components operate independently as separate services within a comprehensive network environment. This architecture forms a virtual supercomputer addressing several crucial requirements: scalability and performance enhancement. This allows the blockchain to handle more transactions efficiently, ensuring faster and more reliable services. Isolation and customization. Each blockchain instance can maintain its own unique characteristics, catering to specific use cases and regulatory requirements. Interoperability, security and privacy, consensus flexibility, decentralized governance, adaptive protocol framework. The architecture can easily incorporate protocol upgrades, accommodating evolving technological standards and security measures. Easy of use accessibility, economic sustainability, and cross-chain communication, compliance and regulation, of course, too. Uh, Now let's delve into our 6 to 4 Web3 ready functional model, a state-of-the-art architecture designed to address our fundamental perspectives: scalable decentralization, interoperability and customization, tokenization and digital twins, and confidentiality and off-chain calculation. Scalable decentralization. It means BFT-like protocol combines with proof of stake to resist Sybil attacks. DAC-oriented ledger, hybrid network architecture, integrates both private and public segments with customizable access policies, parallel transaction execution. Interoperability, modular architecture, transaction families, EVM and WebAssembly support, iron-node paradigm. Tokenization and digital twins, custom tokenization, native DAC token, digital twins, uh, confidentiality and off-chain calculation, decentralized identity, ZKP-based transaction, confidential computing, employs advanced techniques for secure data exchange and processing off-chain. This model provides comprehensive and adaptable framework, ensuring the blockchain is ready for Web3 applications. Each perspective is designed to address specific challenges and enhance the overall functionality of the network. Now let's explore the HNet architecture design. This is a central of our virtualized blockchain system. This innovative architecture divides the network into clusters and segments, each serving specific purposes to enhance scalability, security, and flexibility. Uh, the network is divided into public and private segments. Public segments are open and accessible, These private segments have their own access rules controlled through a certificate system. This hybrid approach allows us for customizable access policy, ensuring both openness and securities. Segments provides flexibility by uh, enabling different level of access and control. Private segments can implement strict access policy and specialized services. Clusters. Uh, each node in the DGT network is part of cluster, typically comprising up to 12 nodes. Within a cluster, nodes vote on transaction using BFT-like consensus mechanism, which ensure high performance and scalability by reducing communication complexity. Clusters can be formed and managed independently, allowing the network to scale horizontally by adding more clusters as needed. This structure improves trust between nodes and enhances performance by limiting the number of nodes, so communication cost is low here. Uh, as to nodes, node roles. To start, we have regular validators in the cluster, then arbitrators. Arbitrators are special nodes responsible for ensuring the finalization of transaction and maintaining network connectivity. They operate outside of clusters, forming a secondary level of consensus and prevent double spending and other attacks. Arbitrators are protected by proof-of-stake mechanism, providing civil resistance and enhancing the overall security of the network. And finally, notary nodes handle off-chain computation and provide access to confidential information. They play a crucial role in maintaining privacy and compliance by verifying transactions in supporting KYC AML processes without compromising sensitive data. By offloading complex computation to notary nodes, the network can achieve better performance and scalability. These nodes ensure that crucial operations like identity verification and confidential data handling are performed securely and efficiently. In summary, this HNet architecture design combines cluster for scalability, segments for hybrid network flexibility, arbitrators to enhance its security, and notary nodes to off-chain calculation and privacy. Uh, Couple words about the transaction family, a cornerstone of DGT platform finance. Isn't just a financial transaction family, it's a comprehensive processing protocol that unifies various banking operation, account management, and token management engines. The DEC family supports a wide range of banking transactions, including wallet and account management, transfer, invoicing, credits, and deferred payments. This allows for seamless financial operation within the blockchain network. Platform provides robust tools for managing any this operation, including mechanism for token emission and minting that control the distribution of token amount nodes. This ensures a fair and transparent allocation of tokens, incentivizing participation and maintaining network stability. That protocol is fully compliant with ISO 222 standard, a global standard for financial services messaging. This ensures interoperability with traditional financial systems and enhance the reliability and the security of DGT blockchain network. Okay. To validate offered architecture, we conducted experiments with various consensus mechanisms. We tested PBFT, lazy way, hot stuff, fast run for virtualized blockchain, and FBFT, Alpine consensus protocols. Our experiments showed significant improvements in performance and scalability with hierarchical architecture. For instance, the fast run implementation of FBFT demonstrated notable reduction of latency compared to traditional PBFT. These results highlight the efficiency of the virtualized architecture in handling high transaction volumes and complex computational tasks. Let's discuss the security measures we have implemented in DGT systems focused on secure or private transactions. We have built upon the Nimble-Wimble model and incorporated several advances of cryptographic techniques to enhance privacy and compliance. Our approach is inspired by Nimble-Wimble original scheme, known for its strong privacy features. We use also Pedersen commitments to anonymize transaction amounts and bulletproofs to ensure these amounts remain within allowed range without revealing them. Notary notes are crucial for handling secure transaction. And we have a comprehensive process here, starting from sender to provide some services to regulators, to financial third parties and other comprehensive mechanism. Once verified, transactions are finalized and recorded on the blockchain. If any issues are detected, transaction can be halted for further investigation. This is very important mechanics to provide some regulatory compliance. As to our tokenomics or economic model to ensure the sustainability and growth of DGT network. First of all, balance between token supply and token design. We use the Fisher equation to maintain balance between a token supply and demand. This equation helps us understand the relationship between the quantity of tokens, their velocity, and the economic activity within that network. We independently modeled the growth of the number of nodes using resource-based equations, ensuring a scalable and decentralized network, simulated the increased transaction volume, reflecting the network's capacity to handle high throughput. We also modeled user adoption, taking into account various factors like network performance and external influence. The token price was modeled using a stochastic system of equation. This approach accounts for market dynamics and volatility, providing a realistic valuation of the native token. An important characteristic used in our modeling is network entropy, that reflects the ratio of users to transaction and the number of nodes involved in processing. This metrics allows us to assess the level of decentralization and the overall health of the network. So this model approach not only addresses the traditional questions of token valuation, but also provides insight into macro characteristics like transaction per seconds or impact on token price over time. Conclusions. In conclusions, I can say the genre of blockchain technology has been marked by significant challenges, many of which stem from irresponsible regulatory actions. Since 2017, organizations like Gartner have recognized blockchain as an emerging technology. However, regulatory bodies such as SEC or FINMA have created substantial barriers through inconsistent and often repressive policies. These regulators have not only failed to provide clear and supportive guidelines, but have also actively discouraged investment and corporate adoptions. Their unpredictable decisions have shown confusions and fear within the industry, marginalizing blockchain and stifling innovation. This marginalization has led to exclusion of well-intentioned and capable participants. The resulting vacuum has attracted high-risk actors and, in some cases, outright fraudsters who exploit the lack of clear regulation. Major failures like Terra or FTX are stark reminders of the consequence of regulatory negligence. The potential of blockchain to revolutionize sectors such as carbon credit, supply chain, organ transplantation, food quality tracking remains largely untapped. This is not due to lack technological capability, but rather the stifling effect of misguided regulatory actions. It's imperative what we all should advocating for informed and balanced regulatory frameworks. Only by overcoming the ignorance and corruption within these regulatory bodies can we unlock the full potential of blockchain technologies. The focus should shift from fear and suppression to fostering innovation and protecting legitimate participants. Let's work together to challenge these obstacles and pave the way for a decentralized, efficient, and transparent future. Thank you.
Thank you very much, Valery. Do you have any questions from the online audience? Maybe everyone is
Yes, I have
sleeping,
a question from here.
so we have
From the
one
audience.
from offline.
Can come closer to the microphone.
Is it okay?
Hi, Valery. Vladimir is here.
Hi,
So
nice,
I
nice to see you.
nice to see you. I have a question about the virtual blockchain. So is the idea that you can connect any existing blockchain there and this virtual infrastructure would be able to intercommunicate between all of them?
Yes, we know some example like Polkadot or something like this. This is like zero level blockchain of blockchains, but maybe more suitable solution is build some gates or bridge from one blockchain to other because of no no clear financial interest to use some huge solution like Polkadot.
And I would just want to clarify your approach. So from the first slides, I thought that
I understand. Our approach is make some bridge to Ethereum or Bitcoin, and then have some solution for real world.
So the DGT will interoperate with the subset of blockchain like Ethereum and Bitcoin, and
Yes.
this will form this virtual infrastructure.
Yes.
Okay, thank you.
You're welcome.
Maybe some other questions? If no, then thank you very much again for your exciting presentation. And I guess let me know if our colleagues from the Federal University of Rio Grande do Norte are here. Someone if the presenters of our third.
It's me. Good afternoon.
Okay, then the floor is yours, and we're ready to hear your presentation. So yes, we can see your presentation.
Okay, I'm gonna start. My name is Vitor. I did this work with my professor Itamir, and it's called a systematic mapping study, blockchain applied to healthcare. So that's the initial study of my master's degree, where we do a state of art review for my research. So the introduction, what's problem we have in healthcare data? And with the advent of big data, the size, complexity of healthcare records are increasing, and they're still not optimized. So it's still a recent problems, today problems, how we manage and how we store and how we access those data. The security of healthcare records is becoming increasingly crucial for protecting data from security breaches and criminal activity. If unauthorized users can gain access to patient data, it can be sold or leaked to the market, with patients' personal information being revealed to anyone with access. So, patients' data is confidential, it's sensible data, and we are searching how we can use blockchain to protect this data. It's hospitals and medical institutions are on the aim of hackers because of the data they store. So what's a blockchain? It's a technology that ensures data storage and transmission is transparent and secure, work without a central control entity, and being secure, decentralized, and distributed. There is no need for a central authority to govern the network. It's a shared management and responsibility. To obtain agreement among the nodes, data are archived via consensus process, and the ledger is distributed and is maintained by all of network nodes. So blockchain's security is archived by many concepts, including cryptography, consensus mechanisms, immutability, replication, and data traceability. So the methodology of this work was proposed by Peterson, and it's development of a systematic mapping study where we provide a structure of the type of research reports and results and have categorized them. That's the step by step. We first define the research questions. After that, we conduct the search. We have the screening of papers. We do a keyword using abstract. And after all, we do the data extraction and mapping process. So that's the research questions that we defined for our state of art. The first one being about the definition of the blockchain. So what are the main characteristics of healthcare applications based on blockchain? The second one, it's the why we are building blockchain applications for healthcare. So what problems do blockchain-based applications try to solve in healthcare? The third one is more technical about development, being what are the blockchain platforms used in blockchain applications for healthcare. And the last one, the challenges. What are the challenges related to healthcare applications based on blockchain? So the search process here, we categorized them, divided them just to explain matter, but it's a search string. Every keyword of this is from a same search string, but here we just categorize it so show our focus on this search. It's the technology one being about the blockchain, the distributed ledger, development based. So we put application, architecture, software system, the programming part. So we put those keywords called smart contract. That's how the business logic is programmed inside the blockchain. Uh, it's how we put code inside of that, how we do the triggers of the code. And chain code, it's the same thing, but chain code is how they called smart contracts on the Linux foundation platforms called the Hyperledger. And the area is healthcare, or how healthcare is used, and what's data it's put on the blockchain. That's the patient's electronic medical records. We do a quality checklist for this search pipeline. So it's more about the structure of the work. So if we have the purpose of the research, if we have background, if they put related work, if they present architecture, if contain research results, and the conclusion. So that's the four stages of filtering. The first one is build the search on Scopus. We have 364 articles. After that, we read the title and abstract analysis called the screening of papers. And the output is 190 articles. After that, the stage 3, we have quality checklist that I presented with 46 articles, and the final output, and being careful, after being careful read, we have 35. So all the data extraction here of this work was about this 35 final articles. Here we have a word cloud of those 35 articles keywords. On the right, we have the timeline, the year distribution of this work. I did this research on the second half of 2023, so that's why we have less article, but we can see that it's growing, the number of papers and research about blockchain and healthcare. So that's the results. I put those on reference, but here the list with the indexes, so we can categorize them, the 35 articles. Here are the categories that we put. The first one being data storage and sharing. The second one, IoT. The third, 5G network. And the last, machine learning. So blockchain, it's about data storage and sharing. So you can say every article of this can be on that category. But when we call the data storage and sharing, we are talking about the data access, the cryptography, the consensus mechanisms. Our research is more focused on those topics. Internet of Things, they are focused on sensors, on mobile, and how they collect data from the patient side. 5G network, it's for application on 5G network slicing and blockchain in healthcare. And the last one, machine learning and blockchain and healthcare. So answering those research questions, what results we have, it's what are the main characteristics of healthcare applications based on blockchain. Blockchain is distributed architecture and decentralization, so we do not depend on one central entity. We have this management of the data being between two or more entities with closed blockchains with permissioned blockchains in the case of healthcare data. We have data security and privacy because the data access are controlled by those smart contracts, and that's are programmed on the blockchain. We have immutability and traceability of the data. So blockchain, it's like a big log. Data, it's append only, so we can see what changes are built inside the blockchain and the immutability of the data. We have data sharing and interoperability. So if the blockchain is shared between entities, we make it easier those share of the same data between them. We do not need to create those patterns between institutions. We have a single blockchain and a single data format and facilitate that data sharing. Real-time processing and efficiency. So if we have consensus and every entity on the blockchain put the data there, the data is already disponible for every entity that have access to the blockchain. And compliance and legal considerations, we can put the rules on, program these rules with smart contracts too. And cost effectiveness and scalability, again, because of those consensus and every data that is stored and every access that we permit inside of it are audible of the blockchain. And support for clinical research and trials, that's a characteristic because of the data sharing. Like if we can control this access, we can control access for insurance companies, we can control this access for pharmacies, we can broaden the scope and make it easier the sharing and the interoperability of this data. So what problems do blockchain-based applications try to solve in healthcare? The privacy and data transparency. So we can prove and show how the data are collected, how the data are shared, who can access those data, and everything of this is auditable. The fragmentation of health data. So we don't have a data of the patient in some hospital, for example, and part of those data in some pharmacy. We try to correct those kind of distributed data that are not trustable, maybe duplicated, maybe wrong. We put only a source, being this blockchain, the source of the patient data. Security concerns in data sharing, centralization and single points of failure, interoperability and standardization issues, authenticity and integrity of medical records, efficiency and cost effectiveness in healthcare management of the data, trust issues, verification and compliance with legal and regulatory standards, like every rules or policy that we have can be audible, can be written, can be seen inside the blockchain through the smart contracts, and scalability and performance challenges. What blockchain platforms used in blockchain applications of healthcare? Here platforms we have Hyperledger Fabric, permissioned blockchain, and Ethereum, a public one, and interplanetary file system, IPFS, for distributed storage, and oracles to access external data to make this between the blockchain and the external data. And cloud computing, virtualization, different consensus mechanisms, and programming language, and custom solutions to interact with the blockchain. So here's a table of those results, what articles we get from this 35 using Ethereum platform, what those using Hyperledger Fabric, the permissioned blockchain, protocol using distributed storage, often used with Ethereum, where we save the patient hash, only the like an index on the blockchain, and the raw data, or maybe the occupy more space inside the distributed storage called IPFS. For programming on the blockchain, we have Solidity on the Ethereum, and Fabric used Go and Rust. So we have application programming language Node.js, Python, and Java, where we build some applications that interact with the blockchain. So what challenge related to healthcare applications based on blockchain? We have scalability and data management. If the blockchain are shared and every node have all the data of the blockchain, this can be an issue for scalability. Interoperability and integration. In that case, it's the integration between already existing systems. We already have a lot of complex healthcare systems on production, and if we are building some blockchain infrastructure, we have to take care of this integration. Security and privacy concerns, smart contract complexity and limitations. It's another logic of building system applications with the blockchain, with smart contracts. Regulatory and compliance issues. If some patient data is only append on the blockchain, maybe they want to delete the data. We have to take care of this on the blockchain as data are saved there. And resource efficiency, energy consumption, and economic considerations. Technical challenges, user-friendly features, and patient-centric control trade-offs. So if the patient have the right or have the power to share the data with some hospital, with some entity, we have a trade-off and another view, another responsibility for the user. So concluding, we have a lot of opportunities because being decentralized, transparent, and immutable record keeping, we have data integrity, we ensure trustworthiness, we have enhanced data security and interoperability. This improves the data management and patient-centric care. We have a secure real data exchange, reducing errors, discrepancy, and combat fraud. We have smart contracts that automate process and increase systems efficiency. We have some challenge, scalability issues, handling large volumes of healthcare data, compliance and regulations. The immutability complicates and can be a legal issue. Integration difficulties, we have, as said, a lot of existing healthcare IT system, and integration with new systems of blockchain can be a challenge. And complex development, the engineering and smart contracts development and logic are different from today's systems. So that's we have a learning curve there. Potential benefits, mitigates the data fragmentation, enhance security and privacy, improves healthcare systems, and we have to look forward developing blockchain system that is scalable, that are user-friendly, and have regulatory compliance. So there's a transformative potential. Blockchain promises a shift in patient data management, another form of we share and access those data, and requires a collaborative approach. So requires efforts from technologies, healthcare professionals, policymakers, and patients. We can look more broader scope, like the pharmacies, insurances, hospitals. That's for the ecosystem of the healthcare, not only the hospital building a system. We can look at a broader scope. Limitation of this study, it's because it is more technology focused, like it's the first step of state-of-art review of building my master's degree. So it's how about the blockchain, what technologies are used, how it's being used. That can be a limitation because we have a lot of social impacts. We have policy and legislation about the limitations of blockchain. For future works, we want to compare how blockchain data storage performance are compared to a normal or a traditional relational database systems, and see the challenges and possibilities of working with the blockchain data as we use today for data analysis and artificial intelligence. Those are the reference, and that's my presentation. Any questions?
Thank you very much. Yes, we have one from the offline audience.
Hi, Vitor. I have a question about the legislation actually. So you work in the area of medical data, and this medical data is especially problematic because you have so many restrictions on sending medical and personal data across the network, and even for medical institutions, there are quite often limitations on the data going out even of the scope of the institution itself. So what are the exact approaches that you found in literature or you can propose or suggest that could handle this? Because it's really a problem to send medical data somewhere, and especially in blockchain, I believe.
Yes.
So what do you think about this? Thank you.
That's today's problems. So we have a lot of patterns and actually laws that were building between those sharing between institutions and another pharmacies or another outside sharing data for outside the medical or healthcare. So we have to take care of how we will build this logic on the blockchain and how we share this logic of how we build as technologies to the external world. So how we make transparent for the policymakers on what and how we build this policy inside the blockchain.
Okay, I have a small hint. Maybe it makes sense for you to look into anonymizing data. So in some cases, when the data is anonymized, somehow obfuscated, you get away from this regulation restriction. So that could be also one of the ideas that you could use in your further research.
Good one.
Thank
Thank you,
you.
Professor.
Maybe we have some questions from the online audience. Maybe I have some small question. In the papers, you look for whether works connecting with some scientific researches, or there were some with the real with practical results used in some medical. So some real results that that are already used in some place. Or
Okay.
you don't search for such, so no keywords about this.
Okay. The question is about a real world problem, like a real production case. Is that, Professor?
Yes.
Okay.
Yes.
We have some governments that are trying to and already build some production environment and build the blockchain applications. But like I said, I built this research following the Peter methodology. So I don't put this on the search string. I just followed my research on the step-by-step filtering the articles that returned. So a lot of them were proof of concept. Not all of them already have a production environment online. Some of them, yes, but the search was not focused on that. Maybe that's the second step of the literature review, of we getting the introduction of this work and the already existing systems. But there are built on some countries already trying.
Okay, I understand. Thank you. If there are no questions, then thank you again for the very interesting talk, and we will go to our next research presentation from our colleagues from Volgograd State Technical University. I guess I see Denis Sinkevich.
I am.
I think you are the presenter, yes?
I am. Yes.
So good day, Denise, the floor is yours. You can share your presentation.
Just a second.
Yes, we can see your presentation.
So let me know if you can hear me, see the presentation.
see your presentation, not full screen, but can see, and we can hear you. Yes.
Now.
Yes, that's better. You can start.
Um, so yeah, at last, good afternoon, everyone. My name is Denis Sienkiewicz, and I'm here and today to present our research on the impact of Ethereum node service centralization on blockchain. So today I'm on behalf of my team and my curator. My team is Alexey Chibrikov, Dmitry Rek, and curator Anton Anikin, me also, from the Volgograd State Technical University. So to start with our introduction, Ethereum is a pioneering, open and decentralized blockchain system that enables the creation and execution of smart contracts. These contracts automate legal conditions, providing security, transparency, and trust without the need for intermediaries. Those may be some interested third party as well. So the importance of decentralization of blockchain technology lies in its ability to distribute control and reduce reliance on single entities, thus enhancing security and trust. So centralization of node services in the Ethereum network refers to the concentration of node operations in the hands of a few cloud service providers. This centralization can impact the network security, efficiency, and trust. In our analysis, we used data from ethernodes.org, CoinDesk, and other academic sources to evaluate these effects. A word about advantages of cloud services. So, cloud services offer several advantages to blockchain networks, including improved accessibility and scalability. These services allow for the rapid deployment of resources, so as we could see previously. This enabling blockchain projects to scale efficiently without significant upfront investment in infrastructure. Additionally, cloud platforms provide tools that simplify the development and deployment of blockchain applications, thereby reducing complexity and costs. About disadvantages, and risks. Despite their advantages, centralized cloud services pose significant risks to blockchain networks. The concentration of nodes in a few cloud platforms increases vulnerabilities to security breaches, such as distributed denial of service (DDoS) attacks. Furthermore, centralized nodes are susceptible to censorship by cloud service providers, which undermines the principles of decentralization and trust in blockchain technology. So, our statistical analysis revealed that a significant proportion of Ethereum nodes are hosted on cloud platforms, leading to centralization. Between 2022 and 2024, the percentage of nodes on cloud services fluctuated, showing a trend towards centralization. As of March 2024, approximately 47% of Ethereum nodes were hosted on cloud platforms, with AWS being the dominant provider. As shown in the diagram, the distribution of node count over time highlights these trends. The geographic distribution of Ethereum nodes highlights the concentration of these nodes in specific regions, primarily in North America and Europe. This distribution is influenced by geopolitical and economic factors, and it impacts the resilience and decentralization of the network. Decentralization in specific regions can lead to vulnerabilities in the network's overall security. The diagram shows the distribution of nodes by hosting type. So we can see the United States, it's about 35.39%. That's a great number, after all. Flashbots play a crucial role in the blockchain production within the Ethereum network, particularly though the MEV boosts protocol. While this protocol aims to optimize the extraction of minor extractable value, MEV, it introduces potential censorship risks. A significant portion of Ethereum blocks processed with the MEV boosts has been censored, raising concerns about the network's integrity and resistance to censorship. To address the risks associated with centralization, we recommend several strategies, encouraging the deployment of local nodes by network users and developers, enhancing security measures such as encryption and regular audits, and developing regulatory standards to ensure the security and resilience of blockchain infrastructure. These measures aim to reduce dependence on centralized cloud services and promote decentralization. So after all, in conclusion, our research highlights the critical importance of maintaining decentralization in blockchain networks. Centralized cloud services, while advantages, introduce significant risks to security, efficiency, and trust. By adopting strategies to promote decentralization and enhance security, we can preserve the integrity and trustworthiness of the Ethereum network. Future efforts should focus on developing innovative solutions that support these principles. So I hope you enjoy this, and I'm waiting for your questions.
Thank you, Denise. Some questions from the audience. And so we have one, maybe.
Hi, Denise. I have a small question. So you talked about Ethereum, and basically we seem to have kind of a problem with the centralization in this network. But there are many other blockchains out there, also like Solana and something else. Do you have an idea? Is it the same there or maybe not? So are there any examples of big public blockchains that do not have decentralization issues?
So this is a good question. Yeah, after all, we studied about another systems, as you said. But nevertheless, I think the question is wider than we can expect. So I can for sure answer it now. It demands a bit deeper research.
So maybe that's an idea for further step then, to see out there
Of course, yeah.
what is it in the other blockchains. Okay, thank you.
Thank you.
Thank you. And no more questions from the online audience. So before we go to our next presenter, I will announce that we have. So I guess we have the author of two missing presentations of the first part of our session. Yes, am I right? Vladimir. So after the next presentation, the fifth, we will, I guess, have some time to listen to the presenter, which must be, yes, it's okay. Before, so the next presenter will be Jasur Kiyamov, yes? Okay, we can hear you. Oh, we can see your presentation, but not yet hear you. Say something, please. I can't hear. So I see that the microphone is online, but no sound here. I don't know why. So, maybe you can change the microphone, use another one. Mhm. You can write in the chat something if you want to say. I guess.
If you want to try to leave rejoin there, I don't know.
So maybe.
Jasur, sometimes it helps if you use Firefox. It sometimes has problems. So maybe if you try Chrome, if you're not using Chrome already, that might help.
Or just leave and enter the room again.
I think it's a problem that it doesn't give the.
Yeah, maybe you did not give permissions.
Yeah.
Yes, exactly. So Vitor is right in that he had also issues with Firefox.
Because we don't see the microphone, I think he never give the consent.
Good morning. Can you hear me?
Okay, we can hear you now. Yes, that's good.
I will be started.
But we have some connection issues.
Okay.
Okay.
Dear colleague, can you hear me?
Yes, now we
Yes.
can.
Oh, okay. I will start.
Yes, please.
In our modern world, cloud technology becoming integral part of the daily and life business. They provide ability, effective store and process data, as well access variability apply anywhere world. However, building is universal cloud system today faced several key challenge, and I will be like to address. As the scale of the growth and the number of particular network incredible, becoming difficult to enough stable operation of discuss system. Therefore, the development of the new approach and algorithm can be cost related fault tolerant become a critical task. Increasable security is becoming notification in virtualization and digitalization make the system more vulnerable critical attack and enough that security of integrate distributed environment becoming on the main challenge that need be addressed. The growth in data will also create a need to form the method analysis process of the neural network, including recurrent neural network allow individual trend and larger volume data which important in making information decisive. As secure access development method to run the resource integration application and creating a robust cloud computing infrastructure are key appraise or challenge. Successful solving the probability will be make cloud system more effective security, which turn will be support and development in information technology and various human activity. The transaction to the cloud system are this cluster of nodes network, which can be two types, public and private network. First is public sharing PPT consensus with providing resource must be publicly accessible and high resolutivity. This segment can be with external network providing data exchange with external nodes. Second is private segment is using a rough algorithm. It's limited to internal use where control and resource management and are great importance. The structure is public-private segment, providing flexible and scalability. A network combination model can be you see in 6 steps of all consensus system. Can be enough as just in all model is can you see me. In first model exchanges messages between network nodes. The block requested integration for block and date and hash. Node send a void again. This approach is important enough consensus if integrate of data of the distribution environment highly and k information with studies blockchain request message interviews and date hash the blocks. The void of the request messages from nodes and consensus with message interleaved date consensus process between node decision making. The second step condition for the making consensus desire. The condition is making desire with enough size accessible consensus. Total number of the void exceed and number of the position error. It's clearly similarly condition application and block desire making, where numbers of blocking must be great and number position errors. The role consensus enough the decisions made only successful support on all the node. Function celebrity leader and collection and process void is highly enhances and K role leading in the consensus process distributed system as well. Third step, the leader select algorithm in RAF protocol is following of the invention for successful leader. Transaction to the view mode and the new processing transition of the confirmed. When received measure of the confirmation as approval of the leading who collect and processing transaction, if the no confirmed, the node begin new round election. Or in full step, with the input the data analyzing time, description, operation nodes, distribution, including load performance, that representing acropublisher representation each time serial secure input vector to train RNN model training data using turn on model minimize prediction between prediction as actual value after the which a model can be used prediction as future nodes detects another temporarily. In 5 steps, we form of blockchain step. First, node collection pending transaction. And second, the nodes are creating the block container and this providing between blocks form chain blockchain. The node calculation the certain be using and hash certain block added backheading this component from formality. In 6th step, your verification of the if all check of the successful node accessible block and add new blocks. This way may be becoming part in the reliability consensus chain. The result be following previous. First, combining of the PBFT and RAF protocol has been performance transaction and consensus distribution. Second, research is confirming system using contribution of PBFT and RAF can be detected or corrected error early. Third of all, reducing the network load due the effect of the protocol, the different method for the data transfer and transaction performance, which reduce all the amount of data transferring and speed up processing. Fourth, multi-layer network based combining PBFT protocol highly resistant malicious attack. If algorithm is evolution network will feasibility enough on a network, this may including analyzing in process error completion and actual date and evolution of the over performance on algorithm. Evolution of the ability modeling detected behavior of the node in the network. This including exemplary model ability detected normal situation such as the attack or failure. Analysis be affected the model prediction system load with preview date. This allows system adaptive and future load change and manage resource effectively. And conclusion, I will say, based on the result of the reach following conclusion and be down. First, the creative the virtual machine implement operation environment and blockchain system improvement step of development on software system. Second, development methodology for launch application multi-level virtual environment early make positively incredible overview performance such complex. Third of all, the development approach building the operation as a using system security and access resource intensive application and heterogeneous distributed cloud system. First of all, the study methodology increasing the reliability of authentication and authorization development method application of the heterogeneous cloud environment and implement component for enough security operation of such sets and complexity. Thank you for attention.
Thank you. Questions from the audience?
I have questions, but maybe not questions, but some highlighting issues. RAF provides some rapid stability. PBFT ensures slow but strong security with high communication cost, and RNN needs extensive asynchronous learning periods. This difference in timing can cause instability in systems. So, Jasur, nice to hear you. How can we reconcile these different time requirements to build a stable and efficient distributed systems? Maybe via some adaptive timing mechanism or layered approach.
So thank you. Your question, whether is it yes, is it impossible? Many distributed system and with Raft and PBFT protocoling, clustering and node with in hybrid system with all public and all private system is structure combination and for a lot of securing in this system we're providing. I will be step and two-step consensus consensus structure with flexible and scalability with this network. Thank you.
Thank you.
So, are there any questions? From the offline audience? If no, we have a question about the next presentation, I guess. So thank you, Jasur, again for your presentation. And yes, we want to listen to the presentation that we can't from some about okay. Maybe I'm a little bit sleepy, sorry. So yes, I want to hear the presentation from the first part of our session this morning from Van Leer, as I understand from FPT University. If you are ready, we can start your presentation.
Hello, you hear me?
Yes, we can hear, can see your presentation. Maybe the sound is not very clear. So you can start from, I know that there were two missing presentations. You can start from anyone. And as we have not a lot of time, so please be short.
Yes, I will quick. Good afternoon, everyone. My name is Hit. Today, I am very excited.
Sorry, not very good sound. Uh, so we can see now, can't hear you clearly.
So it seems that you are talking to another microphone. So like your microphone on the laptop is on and you are talking to the headphones, but we don't hear you. We can barely hear you somewhere far away. So can you check the right microphone?
Hello.
This is better, but now we have echo. So you have two microphones.
Yes. Hello.
Yeah. Yes, now it's better.
Okay. Thank you.
So you can start. It's okay now. I don't understand what has happened, but no sound from you again. So we can see your slides, but no voice. Can you please try to do something with your microphone again?
Hello, can you feel visuals before hit because how hit just my voice has some problem. My paper is revolution payment system integrate RSA encryption NFT blockchain for cash on delivery transaction. This is okay.
So it's not clearly here to
Um, my, can you hear me?
we can. Am I right? You want to make another presentation because your colleague has bad some problems with the sound? Yes.
Yes. I will resend first. After that,
Yes, let's try it. But we have like 20 minutes left for both of you. So time is flying away. So please be quick.
I will resend my.
Can't see your presentation. Okay, yes, now we can see. So please start.
Okay, I will start. Good afternoon, everyone. I'm honored to present my paper titled Evolution Payment System Integrating RSA Encrypted NFT in Blockchain for Cash on Delivery Transaction. I would like to thank the organizer for giving me this opportunity to share my research with you. Let's begin. My content some session introduction, approach, implementation, evaluation, solution. We will start first with introduction. Uh, this paper explores enhancing e-commerce through blockchain technology, focusing on improving payment systems, ensuring transaction transparency, and protecting personal information. Leverage with smart contracts and RSA encryption. Our model addresses the privacy and security limitations of current e-commerce system by introducing RSA encrypted NFT to safeguard sensitive data during cash on delivery transaction. Building on prior research, our approach not only emphasizes user data protection, but also evaluates the suitability of various EVM-supported blockchain environments for e-commerce applications, ensuring a robust and privacy-focused transaction ecosystem. The paper further details our system architecture and implementation, evaluate its performance, discuss future research direction. Next, I will show my our approach. Our proposed system architecture integrates RSA encrypted NFT NFT into the blockchain to enhance security, authenticity, and trust in cash on delivery transaction. Uh, starting with s- s- starting with buyer who request product information and NFT. The system leverages smart contract to manage, track, and the entire delivery process transparently and immediately. A product moves through the supply chain is touched on the including shipper and buyer interact through centralized interface that record every action on a distributed player, ensuring comprehensive transparency and secure. Additionally, our file employ RSA encryption to protect the product detail during transaction, allowing only authorized buyer to decrypt and access this information through their private key to solidify the integrity and confidentiality of the transaction process. The main phase of blockchain architecture incorporates RFT encryption and NFT to secure transactions between seller and buyer. The process initiates with the seller encrypting product information using their public key, public key, and we return it an NFT on a smart contract. This smart contract plays crucial role in facilitating secure transactions by storing encrypted data and interacting with potential buyers. Buyers interact with the smart contract using their unique public key, public key P, to reserve the decrypted the product information, ensuring that only authorized party can access sensitive data. This fact emphasizes the security and integrity of transaction enhancing confidential and safeguarding against unauthorized access through the virtual process. Next, we will the evaluation. Our evaluation of the RST encrypted framework. That's why ISA encryption provides robust security. It requires substantial computation resource, particularly in the key generation and decryption phase. Perform test performance tests on image and test data confirm the consistency and efficiency of the encryption process, but highlighted the high computational demand of decryption. So, this research marks a significant advancement in digital payment system by integrating RSA encryption with NFT within a blockchain framework, enhancing the security, transparency, and efficiency of cash-on-delivery transactions. Our approach overcomes traditional payment system challenges, particularly in securing cross-border transactions by using advanced cryptographic methods alongside blockchain technology. This innovative model sets a new standard for e-commerce transactions, ensuring enhanced privacy and integrity as it points to revolutionize COA practice in the digital economy. offering a reliable and forward-looking solution that meets the evolving demands of global e-commerce. That's all. Time for listening.
Thank you very much. Maybe some short question, but no. So let me. Okay. Thank you again, the speaker. We will make another one. Uh, try to listen to our last presentation, but we have very short time because in a few minutes there will be another session in this room, and they also have to prepare. So let's try the last presentation. Please stop sharing the screen, Van Lee.
Thank you very much. I will talk. Sorry.
Thank you. So we're ready to listen to him. So, are you here with us? Yes, Bundy, please mute your microphone.
Banlep, could you please mute your microphone? You have noises out there. And is the last speaker ready? So Guillaume TP, if you are here, please start. You have 10 minutes. Otherwise, we will stop.
So we can't hear you, and still no presentation sharing. Mm.
Hello.
Hello.
Yes.
Please start and be in a
Yes.
hurry.
Yes. Good afternoon, everyone. My name is Ngim. Today, I am very excited to present my topic, property and pixels, redefining real estate in the digital era at ICCSA 2022. I hope you will find this presentation in interesting and informative. Um, in this presentation, we will cover several key sections. First, we will start with an introduction to the topic. Next, we will look at some related work that has been done in this area. Then I will explain our approach to solving the problems in real estate. After that, we will discuss the the evaluation of our approach. Finally, we will conclude with the conclusion and the preference used in our research. The first is introduction. The traditional real estate system has many problems. These include slow processes, the need for middlemen, and lack of transparency. These issues lead to long transaction times and an increased risk of fraud. Blockchain technology offers a promising solution to these problems. Our significant contribution is the development of secure frameworks using RSA encryption and NFTs for real estate transactions. This framework makes transactions more secure and private, and it can be used on many different platforms. The next is related work. Many studies have shown that blockchain can improve real estate by making it more transparent, uh, efficient, and secure. For example, academic at in this paper talk about how blockchain can reduce corruption in public administration. Um, Pankarov discussed how blockchain can make real estate transactions faster. Hosta and Sadiko highlighted the benefits of blockchain in reducing costs. Our work builds on these studies and focuses on making transactions and data storage more secure. This success approach, our approach use blockchain technology is two-phase. In the phase one, we create a decentralized system where on the different parties involved in real estate transaction can interact through a blockchain-enabled platform. This change how property sales work by using smart contracts and managing public keys within a blockchain framework. This makes the process more secure and efficient. In approach phase 2, we used an RSA encrypted NFT framework to for the transactions. Properties owner encrypt their personal document using robust buyer's public key. These documents are then tied to smart contract that automates the transaction process. An NFT representing the properties is created and encrypted with the seller's public key. This ensures that the transactions are secure and cannot be tampered with. The next section is evaluation. Um, we test we tested our framework by analyzing how well RSA impression work for both image and text data. For image data, the key generation process took about 101.87 million milliseconds on average. Importing the image data took around 75.34 milliseconds, while directing it took significantly longer, averaging 641.01 milliseconds. This shows that while impression and key generation are fast, direction takes more time. The next is the evaluation step. Processing test data was much faster. It took only about 5.50 milliseconds on average. Our framework drove to the adaptable and scalable, handling different types of data uh, efficiently. We also deploy smart contracts on 4 different platforms: Behance, Smart Chain, Polygon, Phantom, and Celo. Among these, Phantom was the most cost effective for deploying smart contracts. The next is conclusion. In conclusion, our study introduced a skill and rapid framework for real estate transactions using RSA's encrypted NFTs. This framework addressed the critical need for security, privacy, and in- interoperability in the real estate transactions. By using RSA encryption, we ensure the sensitive data is secure and only accessible to those with the corresponding rapid keys. The use of NFTs add another layer security and transparent. Our intensive testing approach different platforms so that our framework is adaptable and efficient, making it a versatile solution for various blockchain ecosystems. The last section is reference. Our research is supported by a wide range of studies that explore blockchain application in real estate. These studies cover topics such as secure transactions, data storage, and the overall benefits of using blockchain in this sector. You can find on the reference we used for our research list. Thank you very much for listening.
Thank you very much, but I think we have no time for questions. They're starting another session, so thank you everyone for coming. We're closing our blockchain session, and have a nice day. Have a good time at conference and sessions. Thank you again, everyone. Bye
Thank
bye.
you. Thank you.
Okay, now they listen us. Okay, we can start.
There are all? How many there are? 5,
Yeah,
5. There are all?
I don't know.
There are connected all? I see 2.
2. I think there are not all. Okay, we can wait, I think.
Can you take me a picture of the program?
Yeah?
Thank you very much. Yes. Oh, take me. Yes.
Yeah.
Okay. Try another one. Maybe I change face and high, and maybe I will become more beautiful. Just a minute.
I try my best.
Okay. Maybe. Oh, sorry. Maybe I will leave because maybe the light.
Okay. My. Okay.
Okay. That's it. That's right. Otherwise, I leave and I left you alone. Much better.
Okay.
Much better. Ne. Ne.
Okay, we are free now.
Από τι? Ναι. Ναι. Ναι, είναι. Υπάρχουν υποψήφοι. Από εβδομάδα, γιατί με πετυχαίνετε στο Ανόη στο Βιετνάμ. Από εβδομάδα πάρουμε ένα τηλέφωνο να το κανονίσουμε. Εντάξει, να είστε καλά, παρακαλώ. Δεν έγινε κάτι, παρακαλώ.
Yes, and okay, I think we have only 3, but we missed.
Only 3, but maybe.
Yeah, we missed the first and the last. I don't know if we can start with the other or not.
You are 3. You have 3.
Yeah.
So maybe you can start. What do you think?
Yeah, I think so, but
Okay.
we can start with the second because the first one I think it's not present.
So how is going? I'm talking to them. Can they hear me?
I don't know. Can you hear us? Yeah.
Okay.
I think.
Perfect. Glad to meet you. I'm the chairman of this session.
Okay, wait. I change. Yeah. Okay.
Okay.
Okay. Vabbè. Okay. I think yes. You can start.
Okay. I think you can start now. So the floor, let's say, or the microphone is yours.
Yeah.
Okay.
Okay.
Okay. Please go ahead.
Okay.
Okay. I'm ready.
Yeah.
Okay,
you
go
can.
ahead, please.
Thank you. Hello,
Welcome here.
everybody. Good afternoon. I am Enéas. I am from Brazil. I am professor at the Federal Institute of Espírito Santo, and I am a PhD candidate in computer science at the Federal University of the Espírito Santo. The title of my presentation is Solving the Convection Diffusion Equations via Multiscale and Discontinuous Galerki Approach. This research was conducted with my advisor, Isaac Santos. The outline of my presentation is introduction, discontinuous Galerki formulation, and discontinuous dynamic diffusion method. This is our proposed method. So we present a numerical experiment and then the conclusions. Motivation. Imagine a river flows strongly. So liquid pollution pours into the water at a certain point. The pollution diffuses slowly through the water. The movement of the river carries the pollution downstream. Clearly, convection dominates. The velocity of the river is greater than the diffusion. The numerical solution for equations, that model this phenomenon typically exhibit layers. This is an obstacle to handle this kind of problems. The discontinuous Galerki methods have been widely used in solving convection-dominated problems. These methods capture discontinuities well when solving purely hyperbolic problems and have good stability properties when solving convection diffusion problems with dominant convection. However, DG solutions may exhibit non-physical oscillations near discontinuities and steep gradients. This work aims to minimize these oscillations. We start with the model problems. We have a convection diffusion equations. The first term is the diffusion, the second one is the convection, and the third one is the reaction, and the right hand side is the source. In order for us to be able to read each term of our variational formulation well, we need some basic concepts. So the first is the broken space. We have a tessellation, mesh T8, and we define a broken space where it functions is belong to L2, and when we restrict the function to the element, we have linear polynomials. We have the set of edges. We have the jump and the average on the edge. We use this expression. Now we can present the variational formulation of the discontinuous Galerki. It's a classic formulation. It's not proposed for us. We have a bilinear form on the left side and a linear form on the right side. This is the expression for the bilinear form. We have terms inside the element, and you have terms on the edge. On the edge, we have combinations of jump and average. A lot of terms, so we don't discuss each one. And a linear form is the right-hand side. Again, we have element terms inside the element and terms on the border, on the boundary of the domain. And we have, in this formulation, we have a parameter of stabilization that depends on a user-choose parameter. Our methodology starts here with the space enrichment. The first step in our formulation is to enrich the space V8, the broke space, with bubble functions. These enriched spaces are represented by the direct sum that has a macro scale and a micro scale. We define the bubble function VB that are functions in H1 that when restrict these functions to element, we have H10 that functions that are in H1 and are 0 on the boundary. And we adopt the following bubble functions, that is the product of the functions of the broke space. Here is the multiscale configuration, where at the nodes of the element triangle, we have nodes points associated with the V8, the broke space, the usual space there we find the solution, and we enrich the space with UB in the center of the element, the triangle, the very center of the triangle that is associated with the bubble function space. Now we have a new formulation, variational formulation, is the similar to the classical formulation, but now we add a nonlinear operator. And we search for solution in an enriched space, VE, that is the sum direct of V8 and VB. Here is the linear operator. We can see that we have a term that acts on inside the element and the term that acts on the border, on the edge. This slide is the crucial for our presentation because this is the essence of our method, the way that we compute the artificial diffusion. Artificial diffusion here depends on the residual of the solution, the modulus. And because of that, the amount of the artificial diffusion that we insert on the, we insert on the scheme are self-adaptive. And because of that, we call the method by dynamic diffusion. On the edge, we have the average of the artificial diffusion that is calculated on the elements that share this edge. Since the proposed method inserts a nonlinear operator in the discontinuous formulation, an iterative procedure is employed, giving U8 n in step n, we find U8 in step 1 plus 1, satisfying the formulation. You can see that the un in the operator is the anterior step. We have to lead with the convergence of the iterative process. So to improve the convergence of the iterative process, we combine two strategies. Relaxation scheme. To do that, we have a combination with the actual artificial diffusion and the artificial diffusion that was computed in the anterior step. So in our work, you use omega equals 0.5, and we can freeze in the artificial diffusion too with the residual, the modulus of the residual is close enough to the modulus of the residual of the step anterior, or it means that the residue is not changed. We set the omega equals 0. So in the anterior expression, omega equals 0, it's not necessary. You can see that it's not necessary to calculate the actual, the current artificial diffusion. So we maintain the artificial diffusion calculated in the anterior step. So you freeze the artificial diffusion. To calculate a linear system, to solve a solution, we do not want to increase the degree of freedom of the adaptive formulation. So we need to eliminate the variable associated with the bubble function, the space that we enriched, the V8. In the variational formulation, remember, a bilinear form, non-linear operator, and linear form, you substitute VE, that is the V8 plus VB, with V8 and VB, thus generate two subproblems associated with the macro and micro scale, respectively. These two subproblems generate the following linear system, and through the static condensation process, the variable UB is eliminated from the local system, resulting in a reduced system that retains only the original nodes. This is our method. Now we can present an overview. We start with a standard formulation. So you enrich the space and add a nonlinear operator, split the problem, this occurs locally, and apply static condensation, assemble a global system, and solve the problem. Now we present some numerical experiments for benchmark problems for convection diffusion. Equations are considered to illustrate the behavior of the proposed methodology. The numerical results are compared with the DG method. In all examples, the spatial domain is given by a square of side 1, and we use a regular triangular mesh with 20 partitions in the x and y directions. The first one is a classic problem. The solution is an inclined plane with parabolic layers at y equals 0 and y equals 1, and have a exponential layer at x equal 1, because the conditions are enforced not strongly, these layers don't appear. But at near the parabolic layers, you can see that the DG method presents some oscillations, and our method alleviates this oscillation. Here is the profile, and you can see better the improvement of our method. The next one is a problem that considers a non-homogeneous Dirichlet boundary and have an analytical solution. This is the solution. On the left, we have analytical solution for the problem. In the center, we have the solution obtained by DG method. We can see again that we have oscillation near to the boundary layer, and our method alleviate this oscillation. Here we can see the profile. Now we present a example with internal layer, and this problem has a boundary condition discontinuous. So the solution, approximated solution, is given by the G method on the left. We can see that near to the layer we have oscillation, and again our method minimize this oscillation, the profile, to be better, to see better our method and DG method. And the last one is similar to the anterior example, but now the velocity is not aligned with the mesh. Again, appear a layer, and near the layer we have oscillation when you use the DG method, and our method alleviates this oscillation. Here's the profile to see better the solution. Conclusions. We present a discontinuous and nonlinear multiscale method for numerical solutions of diffusion convection problems. The proposed method is efficient in eliminating spurious oscillations in problems with dominant convection, as shown in the numerical experiments. Even when it is not able to completely eliminate the oscillations, an improvement is observed compared to the discontinuous Galerk method. The proposed numerical scheme presents optimal convergence rates in the norms L2 and H1 as shown in the submitted text. You omit here because of time. Future works, we can consider a multi-scale scenario with additional bubble functions. We can develop strategies to reduce computational cost of the DG method, describe a method to accelerate convergence of the nonlinear iterative process, perform numerical analysis of the method, and extend it to vector and/or transient transport problems. Thank you. Muito obrigado.
Obrigado. Thank you very much for your presentation. I have a question that's say personal. You said you are from Brazil. Which city?
I am from Vitória. I am professor at Piuma, but now I am studying at UFIS Vitória.
Okay, because I was working a little bit in Brazil in Curitiba, Twente University.
Yeah.
Okay. Yeah, it's a little bit. Okay, I would like to ask you because you have not a lot of time and you have some technical problems. I have one question only. Could you please show us the first transparency after this? The photo with the river. The next.
Okay.
Yes, okay, the next. No. Yes. And put also the red schema. Okay. This is if I understand well, this is the problem, eh?
No. This is a motivation, but I think of a formulation of a method. So it's not try to solve a specific problem. That's a motivation.
No, not specific, but you work on this, no?
Yeah.
I mean, based on this, are you trying to do what? To see if I understand well. You try to see how the pollution is diffused after?
Yeah, when the pollution go to the water, the diffusions inside the river.
Okay.
And then the river convects or lead this pollution. We have diffusion and convection here, occur here.
Yes.
And another process like reactions, but don't speak about that.
And the resolution to this, what is from your part? Which is your contribution to this?
My contribution to this is when I try to solve these kind of problems that has convections greater than diffusion. In the model, mathematical model, the diffusion is smallest than the convection. In general, you have layers. That as you can see in the example presented, like a discontinuity. So to solve this with classical methods like finite element, we have a problem. So we need to stabilize like SUPG. So we need to insert something in the classical methods. DG is the way to work with that, but remain some oscillations. We try to minimize these oscillations, but
Did
we
you?
don't. Okay,
Yes.
you can speak.
Go ahead. Did you find after all, after your solutions, did you find a practical way to see if the accuracy of the proposed solution in practice? Did you find something to confirm or to show you that something goes wrong in all this? Did you find something that confirm or not your results?
Yes, you have the examples. My advisor tell me that is the way to initiate a research. So we will have benchmarks. We test with benchmarks, and we see if we compare with the classical methods, and you observe that we have they minimize the solution, have improvement of these classical methods. And we can see benchmarks. We don't try yet on the real problems on natural sciences or another problems. We just we stay in the development of the methodology yet. This is a work of my PhD, and we work on that yet.
Very, very nice. Very interesting. Thank you very much for this presentation and this work. Okay, we will pass. We don't have much time for another question. We'll go to the second speaker.
I think it's Alexander.
Welcome. Bye.
Bye.
Bye. Bye.
Bye from Vietnam.
Bye. Good afternoon.
Good afternoon.
Can you hear me?
Yes. Yes.
Do you hear us?
Do you hear us?
Yes, thank you.
Okay.
I will share the screen.
No, the screen is yours.
Thank you. Can you see the pointer?
Yeah, you can start.
Thank you. So my name is Alexandre. I'm also from Brazil. And this paper is titled Iterated Local Search with Tabu Search for the Bandwidth Reduction Problem in Graphs. I conducted this research with the Professor Sanderson Gonzaga de Oliveira. I am a professor in Instituto Federal de Educação, Ciência e Tecnologia de Santa Catarina, and I am also a PhD student at Universidade Federal de São Paulo and Instituto Tecnológico de Aeronáutica. The bandwidth reduction problem is a well-known and relevant graph layout problem. Researchers have solved this problem to accelerate sparse matrix computations at the beginning. And with bandwidth reductions, this problem is also relevant in several other applications, such as hypertext navigations, analysis of data sets using visual similarity, symbolic models, and a lot of other mesh layout optimizations. The bandwidth for a undirected graph can be defined as the maximum difference of the labels of adjacent vertex. So this S function is a function that label the vertex of our graph and the maximum difference of the vertex that share an edge is the bandwidth. And the goal with bandwidth reduction is to swap the vertex labels to minimize the maximum difference between the new labels. So here we have an example. 4, 3, and 5 are the labels of the vertex of this graph. And the maximum difference between the labels that share an edge is 5. So the beta or the bandwidth of this graph is 5. And if we relabel the vertex of this graph, now we can see that the maximum difference is now 2. So we reduced so there's a reduction in the bandwidth. If we think about this problem in terms of matrices, the goal is to here in the matrix the dots, the black dots are the non-null values, and the white dots are null values. So the goal is to rearrange rows and columns in order to concentrate the non-null values close to the main diagonal. So this is the result of reordering this matrix reduction in the bandwidth when we apply the Sloan algorithm, which is also a classical method. The same matrix here is here, and when we apply the reverse Cuthio-Maki algorithm, another classical heuristic, we see that in this case we reduce the reduction in the bandwidth is even good, even better, because now the non-null elements are very close to the main diagonal. And the reverse Cuthio-Maki method is so important that it's available in lots of softwares and libraries. This is an NP-hard problem, so there's a lot of heuristics and meta-heuristics for this problem, like grasp with path relinking, genetic algorithms, and so on. The method that can be considered the state-of-the-art since 2015 is dual representation simulated annealing, DRSA. And it differs from the original simulated annealing because it's maintained at dual internal representations. In other words, two vectors, pi, that represents the new label of the vertex I, and another vector, rho, that represents the vertex to which label I is assigned to. So it's just the inverse. And the authors defined 3 perturbation operations, and we have to propagate when we modify one vector, we have to maintain consistency. First and second operations are applied to pi vector. First one, and we just exchange 2 positions, random choose, and the second operation, we also choose randomly 2 positions, but the vertices must be adjacent. The third operation is applied to row vector, and it's just a rotation. We propose the method iterative local search with table search, and it takes advantage of both iterative local search and table search ideas. So we also use the ideas of critical vertex, which was defined first by Martin in 2001. And the critical vertex is a vertex that has a bandwidth that is equal to the bandwidth of the whole graph. So it is impossible to improve your solution without improving the solution, the beta of that vertex. And also because local search is kind of It has a great cost in this problem. We also use this concept of the reduced neighborhood, and the local search is just exchanging the vertex of a critical vertex with the vertex that belongs to this reduced neighborhood and prime in ascending order of the value mid v minus the label of the u. And this is the algorithm, and we call ILSTS. It has as an input, you must give the graph, the number, the maximum number of iteration, and the size of the table list. Here in line 1, R0 represents the solution, is a vector of labels. And initial labeling is given by the reverse Cauchy-Mackey method that I talked earlier. And we initialize the table list and iterations and the level of perturbation. Then we apply a local search and assign the solutions to R, and we calculate the bandwidth and assign it to beta. In line 5, we apply the perturbation in the solution R with level and table list as parameters. I will talk about this in a moment. And then we apply local search. If the solution improves, we update the solution and we reset iter and level. If the solution do not improve, we increase the level of perturbation, and here are the perturbation method. We have here in line 3 to find the critical vertex and vertices, and we choose one randomly and assign to u, and then we choose another random vertex, but without considering u, and this set of vertex u and v must not be in table list. So we swap the labels of u and v, and we insert a u and v in the table list. We also use a benchmark for our tests, and we use 82 matrices from the sweet sparse matrix collection. And we implemented this method in Rust version 1.69, and we use the compressed sparser row or Yale format, because in this format we do not represent null values and we get more cache hits. We conducted all the experiments in a simple computer with i3 processors and 8 gigs of RAM, DDR4, with a GNU Linux kernel 5.15. We established the parameters iter max at 200 and k for the table list at 50. We also used the results found and reported by the authors of GRSA, because we tried to run the GRSA, but it took too long, even hours in some big instance. So here we have the instance, the graphs, the number of vertex. Beta 0 is the bandwidth, original bandwidth. Here are the results of GRSA reported by the authors. Here are our results, and here are the time that IOSTS took in seconds. We can see that in only 3 graphs, the IOSTS, our method, was better in only 2 cases, and in 5, it was a draw. In 2 matrices, IOSTS found 10% close results compared to GRSA, and in 5 instances, the results were worse by a margin of 20% or less. And here we have a figure to compare. The orange dots are IOSTS and blue dots are GRSA. We can see that GRSA it's better in almost all executions. And to conclude, we implemented this hybrid meta-heuristic algorithms to leverage the characteristics of iterated local search and table search, and we compare the results of the state-of-the-art GRSA. This instance ranged from about 200 vertex to about 1,000 vertex, so it can be considered a small matrix. The results demonstrates that in terms of bandwidth reductions, our proposed method has good results while maintaining low computational cost. It was fast, but it does not achieve competitive results when compared to the state of the art for this problem. So due to its reduced computational costs, IOSTS is a good candidate for situations that requires bandwidth reductions with low computational costs. And in future work, we intend to verify if that's the case for when applied to a large instance. And this is necessary because this methodology or this proposed method, it's a novel proposition. So this is some reference I use in these presentations. And thank you very much for your time. This is my email.
Okay, thank you very much. It is an interesting subject. Do you have any question? Maybe one question because you don't have so much time. No? Okay, we don't have question. Thank you very much. Greetings to Brazil from Vietnam. I wish you to succeed to your research. Thank you very much. Bye
Thank
from
you.
Vietnam. Okay.
Bye-bye.
Okay, let's go to the next speaker. We have the two last speakers.
Dovrebbe esserci lui.
Okay.
Ok.
Good evening.
Okay. Good evening. From
Italy.
From Italy.
Yes.
Okay. Okay. Well, listen you. The floor, no, the screen is yours.
Thank you. Could you see my screen?
Yes.
Okay.
Could you please put it in full screen presentation?
Yes. Give me a moment.
Yes. Perfect.
Okay.
Okay.
Good evening, everyone. I'm Vladislav Skilsky, and I'm currently attending my master degree in mechanical engineering at University of Campania, Luigi Vanvitelli. And today I'm going to show you my project. I've been working with PhD Viola Rossano and my professor Giuliano De Stefano, which is named CFD Analysis of Turbine Cascade and Steady Aerodynamics using a hybrid POD technique. Here you may see a brief list of the topics that will be covered during this presentation. And let's start from saying that one of the main problems in industry is that simulations are very hard to achieve with a high accuracy, and they require days or months to be completed. And each year, industry applies low fidelity methods, which, however, tend to neglect several physical behaviors due to significant computational cost. And the objective of our study is speeding up the process of calculating the flow field, specifically around a low pressure turbine, using reduced order models, which we are going to refer from now on as ROMs, which are computationally light models derived from more complex physical models. They have its own advantages, which are computational efficiency, since they reduce computational costs compared to full order models. They require less memory, and they may be combined with neural networks to improve accuracy with machine learning. There are several methods of reduced order models, which are proper orthogonal decomposition and so on. The one that we are going to use in this, we used in our work is the POD methods. And on the left, we can see how we can reconstruct the model with a reduced one, starting from a full order. They have several field of use, from mechanical to electrical to thermal and fluid in our case. And we always can start with spatial discretization like FDM, FEM, FVM, extract some snapshots and use them for our POD algorithms. They are important. Why? Because modeling via FAM and FVM is becoming more and more important each year. They may be applicable for several physical domains, and they have different applications as we saw before. The ROMs are also indispensable because they reduce computational effort, mainly with the linear ROM, and they do not require any simulation to be used. The motivation of our study. Why did we start this study? Because as I said before, one of the main concerns in industry is time. The simulations require very long time, they require days or months. They require high-end components on the machines. And in our specific case, the low-pressure turbines are highly turbulent. And how do we want to achieve this? First of all, we are going to use CFD to calculate the flow field. We then develop an algorithm that learns how the fluid evolves, and then we compare the result to validate our results, comparing the POD with the CFD. Our study case is a T106 turbine, mainly used in jet engines, as you may see in these pictures. As you may see these pictures, as well as in energy conservation turbines, which are used in industry to extract energy from hot gases. We then researched a few studies, and there are few applications for POD, especially for transonic flows. There on the bottom, you may see a few papers we consulted, and no one of them is on POD. First of all, we started with this grid, and with these boundary conditions on the inlet, we used a hybrid runs and less model, and we extracted 33 snapshots. We then transformed our unstructured grid in a structured one, so it is more precise and easier to work on. We then arranged all the snapshots in a matrix. We performed the singular value decomposition, and then we reduced this using the proper orthogonal decomposition. We then used two algorithms, a linear POD and a POD Gaussian process regression. The first one interpolates all the points with a linear interpolation, which on its own advantages has dimensionality reduction. They are very interpretable since they are linear, and they require a low computational cost. However, we are assuming that the phenomenon is linear, which is not true for more complex physical behaviors. Then we used also the Gaussian process regression which is an algorithm that extracts a function of the velocity of the pressure field. It is flexible, and it offers an uncertainty estimation. However, it requires a higher computational cost, and one of the main concerns is the choice of an appropriate kernel. We observed 33 data, and we used for the linear POD 70% of these data, and for the GPR 90%, since the linear is precise even with less data, while the GPR has to extract a function, so it needs more training data. Then here is a comparison between the CFD and the linear POD, as well as the POD GPR. We extracted 5 time steps, all equidistant one from the other. And as you may see, in the first, there is a highly similarity with the CFD between linear and CFD. In the in the second one has some minor differences on the tail, as you may see, some vortices that are not present in the linear POD. Then in the third, we have some minor differences on the leading edge as well as on the tail, and the same with the fourth. Which has some major differences on the leading edge. And lastly, the same with the fifth. Some major vortices may be not present. However, as we will see later, in the end, the error is very limited. So the method is pretty accurate. Then we did the same with the POD GPR. As you may see, the first snapshot, the first time step, is a little bit different between the two. In the second, the vortices are quite different between CFD and GPR, as well as in the third, where we have some major differences on the tail and on the leading edge. And then on the fourth, there are major differences on the leading edge in opposite of the previous linear POD that has minor. Same with the fifth. However, here as well, we have a low error, as you will see soon. Then after this, we compared the linear POD and the POD GPR in a brief animation here. As you can see, the differences are not very important. The only maybe problem could be the leading edge, as we saw before, that has some major differences on the vortices predicted, as you can see here. However, we also made an accuracy estimation, and as you can see at the beginning, we have a relatively small error that increases with the snapshots, and that is justified by the fact that when we go more and more forward on the time step, we are expecting more vortices that are a little harder to predict in opposition to the beginning. However, the error is limited below 1.5 for the velocity field and below 0.5 for the pressure field. We then also extracted the median error that you can see on the bottom right corner, which is acceptable for the preliminary study that we have achieved. So there could be some differences in the snapshots. However, the accuracy is high for the moment. Then I want to summarize all the results that I have covered. We first of all made a numerical simulation to study transonic conditions. We then transformed the grid from unstructured to structured. We then performed a POD linear and Gaussian algorithm to predict the transonic flow. We used the two different codes showing how POD may predict flow fields with accuracy, speeding up the process of calculation because it required very few minutes. POD GPR show less accurate predictions, but this is justified by the fact that we had limited snapshots, and in this preliminary study, we expect this. And for future developments, we are going to test accuracy as the number of snapshot changes, and as well we want to integrate the deep learning to the previous algorithms to improve the accuracy. Thank you.
Thank you very much. Unfortunately, we don't have time for questions. Thank you very much anyway for your presentation. And we will pass to the last. Speaker. Please go ahead. The screen is yours.
Hi, can you see me?
Yes, we can see you. And
all right. Can you also see my screen?
Yeah.
Okay.
Yeah, we can.
Okay, perfect. May I start?
Yeah. If you can put full screen, please.
I think I'm sharing right now.
Yeah, you are sharing, but it's not in full screen.
Sorry, that's not my screen though. I can see a WhatsApp chat right now.
I don't know, but I think I see all the PowerPoint, but not only the full screen.
Okay, let me try again.
Yeah, thank you.
How about now?
No, now is the same like before. I
Still
don't
the
know
same?
why. Yeah, I don't know why. Wait a second. Hold on a second. Just a few seconds.
Yes. Can you hear me?
Yes.
Yeah.
It's okay?
Yeah, it's okay, but we can't see in full screen.
It's okay.
Okay.
I don't know why, because
the full screen is just in the orange bar.
No, yeah, he put the full screen, but never see. I don't know why.
Okay.
Yeah.
Doesn't matter. Let's go.
Okay. I start. Okay.
Yeah.
Okay. The last speaker.
Yeah.
Yes.
Okay. The screen is yours. Go ahead.
Thank you. Thank you. Yeah. I'm sorry for
our afternoon session.
Okay, I'm really sorry for the inconvenience, but thanks for having me. Good morning. My name is Antonio Mezzacapo. I am a second year PhD student at the University of Campania, Luigi Manvitelli. And today I'm going to present you the numerical investigation carried out by my supervisor, Giuliano De Stefano, and I, named CFD prediction of a supersonic jet impingement on an inclined flat plate. The talk will be so divided. In the first part of the problem, I would like to give you a very briefly overview of the problem description, highlighted one of the most important applications both in the academic and industrial world. Also, I would like to bring to your attention some of the previous experimental and numerical studies carried out in the past in the field. Since many of you might not be aware of the physics behind those systems, I also would like to give you provide you with some insight into jet flow characteristics. And finally, I would like to present you the preliminary results we got from a qualitatively and quantitatively point of view, listing up some of the conclusion and future work. As I already said, physics behind those systems might be very complex, and the applications are many. In particular, they go from the design of a jet deflector, what are those systems that are that prevent people from injuries due to the high speed of the exhausted flow from the roar of the engine. But also understand the physics of those complex allows us to design a more sophisticated nozzle in order to optimize the thrust from the takeoff phase of a missile or a spacecraft. And finally, also understand the physics allows us to design more sophisticated vertical launcher system that are those sophisticated devices installed on ships or maybe submarines that are using to hold and fire missiles. As I said, different experimental and numerical studies have been conducted in the past in order to investigate the complexity of the fluid flow and also trying to provide an accurate physics description of the flow itself. In particular, the early experimental study in the field was carried out in 1980 by Lemont and al., in which for the first time they simulated the impact of a jet, supersonic jet, on a plate with an angle of 90 degrees. Next, the experimental study carried out by Nakai and al. In 2006 represents still today one of the most important significant work in this field, because for the first time they simulated the impingement of a jet on an inclined flat plate for different plate angles, different pressure ratio, and nozzle plate distance. In particular, they implemented very sophisticated experimental techniques like the pressure-sensitive paint in order to obtain the distribution of the pressure on the plate, and also the shrouding method that was used to visualize the fluid flow. Numerically speaking, instead, most of the numerical analysis have been conducted using the traditional unsteady Reynolds average Navier-Stokes approach in order to analyze and visualize the flow characteristics of those systems. As I already mentioned, the physics behind the system might sound very complicated. In particular, there are different regions. The near field flow structure depends primarily on the operating condition of the nozzle. In particular, they depending on the Mach number at the exit of the nozzle and the static ambient pressure. Therefore, selecting the jet exit number and the pressure ratio PR is very crucial, because if we slightly change the pressure ratio, also the physics involved in those systems tends to change and is completely different. Several flow regions can be distinguished. In particular, we have the potential core and the free jet core. That is the region, it's this region, as you can see in the picture of the flow, where the jet doesn't feel the presence of the wall itself. Therefore, this part of the flow is very easy also to describe mathematically, because we have a lot of turbulence model that allows us to do that. Whereas the region of the problem arises when we approach the wall.
Sorry. I would like to ask you.
Yes.
You change your first.
Yeah.
Because you still in the first
slide.
Yeah, I'm still changing the slides, so it's you that.
Because you didn't see.
Yeah, now we are at the 5.
You have the first slide, jet flow characteristics.
Can you see now? Can you see now?
Yes, now yes.
Yeah.
Okay.
Okay. Sorry.
Please, okay, this is introduction, okay, problem description, okay, go ahead, results, case study, okay. Now you see a little bit, okay?
Okay.
No? Continue?
Yes, I was here, like, so you can see in the picture.
Slide 2.
We are at
You
the
are in slide 2.
now at the 5.
No.
3,
okay.
5, okay.
Probably
Now you are in slide 5.
Okay, maybe I don't have to share the screen on my computer, otherwise you cannot see. Can you see now if I move the slides?
Yes, now
I do this way. I do this way. Okay, so I was saying that due to the fact that there is a pressure difference between the ambient pressure here and the nozzle, shock waves are generated, and these oblique shocks wave are generating, and they interact with the wall on the bottom, and they create a very complex mechanism of compression and expansion waves that can also increase the aerodynamics and thermal loads on the plate. Regarding the computational setup, the flow geometry consists of an inclined flat plate and a converging diverging nozzle in order to generate the supersonic jet. The numerical analysis that I've been conducting this presentation I took inspiration from the one by Daravar and all, even though in our case we used to reduce dimensions in order to save on the computational time. The throat diameter is equal to 5 millimeter, whereas the nozzle axis diameter is equal to 7 millimeter each, and the domain extends to up to 21 diameter along X, 75 along Y, and 28 diameters along Z. Whereas regarding the flat plate, it has a dimension of 50 meter, 28, and a thickness of 0.25 millimeter. More about the computational setup. The plate nozzle distance, L over D, is equal to, and the inclination angle is varies in the range of 30 to 50. And those is the same configuration that was used both by Nakai et al. And Daraba. Since we expect the flow to be symmetric, only half of the computational domain has been actually simulated. Regarding the computational grid, we use a hybrid mesh approach. In particular, the region close to the plate has been meshed using a structured approach, a structured grid, then hexahedral to be exact. Whereas as we move away from the plate, we switch to tetrahedral elements, therefore an unstructured approach. And particular attention have been paid in order to ensure a very smooth shift from structured to unstructured grid, so that the commercial software HANSYS could correctly capture and estimate the gradients. A total number of 3 million cells has been used, and the first point of the mesh around the plate it has a Y plus equal to 35. For the boundary condition, they are the same used by Daravan and all. At the inlet, we imposed a pressure inlet boundary condition with a total gauge pressure of 10 to the power fifth, whereas the supersonic total pressure is 25,000. That has been obtained using the isotropic flow Mach number relationship reported above, in particular the one in the middle. Whereas for the outflow, we use a gauge, we use a pressure outlet, and we imposed a gauge pressure equal to 1,336 Pascal that allows us to have a Mach number at the exit equal to. Whereas for the plate, we use a no-slip boundary condition, and the plate has been considered perfectly smooth. And for the symmetry, we impose a symmetry plane so that the flow on along the normal flow are equal to 0. For the turbulence model, in the first part of the analysis, we use the RNG K epsilon model as a runs approach. And the reason why we went for this model is because this model is well known for its robustness, economy, and reasonable accuracy. But especially because this model, compared to standard K epsilon turbulence model, that is not affected by the round-off anomaly, as described by Pope. That simply means that turbulent kinetic energy in the stagnation region is said to be overpredicted. Once we got reasonable accuracy from in terms of results, we shift to more sophisticated techniques like the DES approach that stands for the touched eddy simulations. The turbulent kinetic energy and the epsilon, the dissipation rate at the inlet and outflow are being estimated using the hydraulic diameter at the inlet, sorry, and for the outflow we use the viscosity ratio. More about the numerical parameter. The following we use the commercial software ANSYS Fluent.
No, sorry, we
sorry a little bit.
And we have problem with the microphone. I don't know if
the microphone.
It's not mine.
It's the volume. You have to.
Yeah, I don't know. I don't know if it changed something.
You changed something?
No, I didn't. How about now? I'm reducing the.
Now it's okay.
It's okay now. Okay.
Now it's okay. Something changed
okay.
Before. It goes,
all right. It's okay. Okay. May I continue now?
Yes. Yes.
Okay. Thank you. So about the numerical parameter, we use the ANSYS Fluent software, and for in order to carry out the calculations. Whereas for the time discretization, we use the first order implicit error method with a time step of 10 to the minus 4, so that the current number is kept approximately equal to 0.75 along all the calculations. Particular attention I will be posed to the discretization of a pressure, because so that we use a second order accurate scheme named Presto. We set the residual criteria for both the velocity and energy equal to 10 to the minus 6, and we used under relaxation factor in order to increase the stability of the iterative process for both decay, the turbulent kinetic energy, and turbulent dissipations. And in order to assess the convergence of the solution, we monitor the pressure plate distributions. Okay, now I'm gonna show you some of the qualitative analysis results that we got. And in particular here, I'm going to show you the velocity contour map for both the Urans and the DES calculations for a pressure ratio equals 7 and a nozzle plate distance equal to. This is the same setup as Nakai et al. And Daravar et al. And the results are presented for different plates angle from 30 degrees to 50. In particular, looking on the top, so at the Urans calculations, we can notice the presence of the stagnation region is the region where the velocity reached its minimum, whereas the pressure its maximum. And we can notice that as we increase the angle of the plate, the stagnation region, the presence of the stagnation region tends to move towards the up part of the plate. This means that also the pressure tends to decrease as we increase the angle. The same happens for the DES calculations, but here we can notice that we can get more insight into the flow, because if we look at the 40 degree and also 50, you can notice that inside the stagnation region we can notice the presence of recirculation. That, as I mentioned before in the previous slide, this is very typical when we deal with the physics of those systems. Here, in the next one, instead, I'm going to present you the pressure, density, and wall shear stress from the top to bottom from the Urans calculation in this slide, and for the DES in the next one, for the same pressure ratio and the same distance. As I already mentioned before, the pressure ratio, as you also will see also in the quantitative analysis, the pressure peaks tends to decrease in terms of magnitude as we increase the inclination of the plate. So it's maximum at 30 degrees and it will be lower at 50. And the same happens for the density and wall shear stress. What I highlighted in this slide, but also in the next, is that the CFD tool is very interesting because it allows us to get more information and extra data from the experiment, because sometimes the experiment cannot give us such data like the wall shear stress, because in order to do so we need to introduce some intrusive measurement that when it's about supersonic flow or hypersonic flow, they tend to compromise the flow. So the information that we got from the experiment, in a few words, are not really trustful. The same is for the desk calculations, and we can notice that there is on the plate, at least, there is not a very big difference between the two. That's because the desk approach tend to combine two different approaches. In particular, near the wall and at the wall, the runs approach is used, whereas in the flow in the far field region, I mean away from the wall, the LES approach is used. Here instead, I'm going to show you some of the quantitative results, in particular the pressure distribution on the plate for 30, 40, and 50 degrees. Here, you can notice that the graphs are in a non-adimensionalized form. In particular, the pressure has been non-adimensionalized using the pressure inside the nozzle, whereas the Y, that stands for the length of the plate, has been non-adimensionalized using the radius of the nozzle. And here I compare the results that I got from the K epsilon, that for our RNG K epsilon turbulence model from the runs calculations, from the desk calculations, and I compare them with the experimental results that are derived by Nakai and all. Here we can notice that both the numerical approach tend to correctly predict the pressure distribution on the plate in terms of location of the stagnation region, but also the magnitude. As we saw in the contour maps, we noticed that the location of the stagnation region tends to move towards the up part of the plate, and at 50 degrees is also it's very evident. But also the pressure peaks tend to decreases as we increase the inclination angle. Right. In order to conclude, we can say that this research show that is successful simulate using commercial softwares like ANSYS Fluid, a supersonic jet impingement on inclined plates using two turbulence modeling approaches. And we were able to show that if we are interested only at the wall, that there is no need to use more sophisticated model, but we can simply go for very easy one that are faster but also cheap.
Sorry, sorry.
Stop.
We are problem.
Again, the same problem with my
No.
It's okay?
No.
Can you still hear me?
Wait a second. Okay, just a second.
Yes. Thank you.
Can you hear? Can you speak?
Yes. Can you hear
No,
me?
I can't hear you. Just a second.
Yes.
Maybe now, I don't know.
Oh, okay.
Yeah, but
What's the issue?
The only exit for the song.
do you hear me?
Yes, clearly.
Yeah, but I don't hear
No,
you.
because you cut it, because there is no other exit.
Maybe.
Otherwise, it will be only from the laptop.
Yeah, I think.
You have to open this.
Yeah, but they maybe I don't know. We have some problem of with the audio.
Oh, because I can hear you clearly. Can maybe
Just a second.
yes.
Okay, do you try to speak?
Yes. How about now?
No, I didn't hear you. Just a second.
Use.
Try.
How about now?
No.
Let me try. How about now?
Just a few seconds.
Yes. Oh, okay. Thank you. Okay, I see.
Can you try again? I tried to fix. Can you speak, or maybe I don't listen you? So, do you hear me or not?
I can hear you.
Okay. Okay. Now it's okay. I hear you. So Antonio, do you hear me? Maybe Antonio cannot hear me. Okay. Maybe we have fixed, but I don't know.
This is okay.
Yeah, because
Hello, can you hear us?
Antonio was speaking.
Antonio, can you hear us?
Someone.
Yes, I think it's.
Someone, can you give us a feedback if you hear? Yeah.
Yes, I can hear you.
Okay, but we don't hear Antonio. Okay. Yeah.
What?
Don't use the speaker because
What you would use? Otherwise, it's the only exit.
No, we can use the exit.
The exit from the computer.
Yes, for now, yes.
For now, okay.
I don't know if
The last, but
fortunately no.
How about now? Can you hear me?
Now okay, now I listen you.
okay.
Okay, I
Can
hope
you hear
the
me now?
problem will finish.
I try to speak without my headphones, so maybe that works.
No, I think it's our problem. It's not yours.
Okay. Can you hear me now or?
Yeah. You can continue. Sorry
Okay.
for the
No, it's
problem.
perfectly fine. We are at the conclusion. We can still make it. Okay. Then I would say that as I said, near the wall, there is no need to use more sophisticated turbulence model. We can simply use semi-empirical model, in particular the RNG. But at the same time, as I showed in the contour map, if we are more interested in to get a very overview of the physics, then we need to shift to more sophisticated model like the DES, because it was the only one in order to capture the recirculations in the stagnation region. But anyway, both the approach, Urans and DES, correctly computed the pressure peak and the location of the plate in comparison with experimental results. As future work, what I would like to do, I would like to use a variation of the DES model named the delayed attached eddy simulations, and trying to investigate such modification and how it behaves in terms of the computational effort and the accuracy. But most important, I would like to use more sophisticated computational model like the V2F turbulence model by Durbin and Hall from Stanford University, in order to take into account the anisotropy of the wall, because most of the turbulence models that are used in the academia, but especially in the industry, are based on the assumption that the structure of the wall are isotropic, but that's not the reality, because in reality, as I said, the structure anisotropy, and this also has implications on the quantity that we measure. Therefore, I would like to compare the V2F turbulence model with the DES and the Durant's approach, and understand how those models behaves in terms of prediction of the wall shear stress and heat transfer coefficient. And what I'm working right now is I'm testing open source code. In particular, I'm using OpenFOAM, and we are trying to investigate the ability of the code in order to, and the accuracy especially, when it's about to simulate supersonic impingement jets. Yeah, those are the reference that I use, and I think that we made it. That's everything. Okay, so yeah, that's everything. Thank you.
Antonio, thank you very much.
Okay, I'm really sorry for the technical
problems.
issue.
No, it's not your fault. Probably it's from here. Thank you very much. With this presentation, we arrive to the end of this session. Thank you again, and greetings from Vietnam.
Thank you. Yeah, thank you.
Bye, Antonio. Bye. Thank you.
Bye all.
Bye all. Session is closed.